Okay, that's what we're talking about, the lab number 13, a new one. I get a lot of problem. You can see for software to generate the schematic and this IC memory, I couldn't find any. So that's why I have to do this way. Okay, so you have to understand when they're telling you, okay, in the program here, okay, the first test, test U1, U2, U4, data 0855, okay? So now, if you run the test, it will fail test number one. Okay, we'll see what can we do. Okay, we'll see what can you do. They say U1, U2, U4. So basically, you're looking into the program. They say drive to port A. Okay, 0855. And number two, they apply the clock. Enable U1, enable U2. And finally, verify. Pass or fail. Okay, so now, Okay, if you're looking into schematic, they drive port A to U1, and that they go to U2 to go to port C for verify. However, you can see what's going on. Both things, when they fail, okay, what can you do? You know, what can you do? Just telling me.
Well, first thing you check for power and ground. You make sure there's power, but then you could check for the output on IC1 and then check uh U2 and output.
Okay, what can we do? Number one, check power and run. Okay, that's good. Number two, now you get that two way to do. First thing you need to check the output of U1, right?
Right.
Okay, check output of U1. Okay, four. Okay, 0, 1, 0, 1, 0, 1, 0, 1. That means 5, 5. Okay, now after you check, either you get what you want or no. So now we can tell if you get the correct, okay, the data is correct. When I say check the output, that means, sorry, you have to using the DMM to measure L1, pin 2, pin 5, pin 6, pin 9, and so on. Okay? If data is good, then what to do?
Go to U2 input.
What next step you have to do?
U2. I see U2 input. Check.
Okay, good. Take you to input, right?
Yes.
That will be pin 2 to 9. Okay. When you take pin 2 to 9, if it's good,
Check output.
okay, 3.2. If good, okay. You say check output yêu chuộng. Okay. Then when you check the output yêu chuộng, either good or not good. Now I just talking about good. 3.3. Data is good. Then what next?
U49.
What
U4
can we
pin
do?
9.
What?
U4 pin 9.
U4. No.
No?
The thing is you already checked U2 output
Mm-hmm.
5.5. But the test it failed.
Hmm.
So
And,
that's a system problem.
Mm.
That means you see output U2 okay, how come they fail? So need instructor.
Yeah, no kidding. Okay.
Okay?
Mm.
So that really make it clear when it failed that one. Okay?
Okay.
And what we have to follow that to do. Okay? So you take power and now take output if data is good. Okay? Now the data is not good. Okay?
On output on you too?
Yeah,
Okay.
that means when the test is fail.
Mm-hmm.
Okay?
Mm-hmm.
Then now, okay, you can take output of U1. Okay. If it's good, okay. So now in here, now take off U1. Data is not good. Okay. If it's good, you're already done. Okay.
Mm.
So now if it's not, that means output 455, they not good. That means they read it wrong. Okay. Now what can you do? Okay. So I can put in here a 4. Okay. 4.1. Okay. Now it's not good. Then what you have to do? That means when you run the test, they fail. Okay. And that one, the first one, I telling you. Okay. Take output A1. It good. you can do. Take you to input Q9. That means the input you choose is good. Okay. The data good, then you need, okay. And you check output of U2. That means that output here okay, but fail. Then you need the instructor to help you. Now the next thing is the key point here. You check output of U1 55. Now the data not good. We don't have to. Data not good. That means you check at the output of U1.
You
Data
check
not good.
check the input
Oh,
and check the clock.
okay. Now you know more, right? Oh, okay. Check the input. Check U1 input. For 0101.
Mm-hmm.
0101.
Mm-hmm.
Okay. Now 4.4. Data is good.
Mm.
Then what next?
I replace IC.
No, not yet.
Not yet? Oh.
The thing is you check the output here is wrong, right?
Uh-huh.
Then you go back to the input U1 from port A. Data in input port A here is good. That's why I say check U1 input. And now data here is good. Okay? And
Mm-hmm.
the data output is not good. First thing you need to check the P clock, right?
Yes. Yeah.
Okay. Then first thing, check P clock. Okay. This need no add software. Okay. And OSC, oscilloscope. Okay. 4.5, 4.6. Clock good.
Replace IC.
Then what you do?
If the output is still not good, replace
Yeah.
IC.
Yeah.
Something wrong with the IC.
No, not yet.
Not yet. Oh.
You understand is 374. That's a D flip flop.
Mm-hmm.
Okay. When you apply right to port A, okay, then you apply the clock. The data port A will be go inside the IC, not outside, inside.
Hey, Mr. Freeman,
Okay.
quick question.
they will be going out of the IU1 if the pin number 1 is 0. That means enable. Okay?
Mm-hmm.
Pin number 1 must be 0. So
Mm-hmm.
data inside IC can go out.
Mm-hmm.
So that's why you have to check.
Oh, yeah, I'm sorry. You're right. Make sure it's 0. What were you going to say, Joseph?
Okay. Then it clock good. Then check U1 pin 1 equal low. Okay.
Yep.
Now, either you can see it low or not. Okay. If U1 pin 1 low, then what?
Then replace the IC.
Perfect.
If everything is working and it's still not
Okay.
working.
Okay. Good now.
Okay.
Ah, that mean, that mean
Something is,
remove.
yeah, and replace.
Exactly. Remove and replay. You what? The thing is when you come up to me, you say, you told me, okay, I want to get a new you what? Then I can asking you how come you want to change the you what? Okay? And you can say input you want is correct. They get the clock, they enable. How come output they not correct? That mean at work. However, this is in the lab will be a minor difference. I can telling you. For example, you see the L1 pin 3 at the logic 1, then L1 pin 2 have to be at the logic 1, right?
Right.
If it's working. Now, L1 pin 2 not at logic 1, what do you think you can do?
Well, you start checking everything and see
You,
what,
that means you already setting the input L1, right?
uh-huh,
Correct. You check L1, pin 1 low, correct. You
uh-huh,
get the clock, correct.
right,
Output supposed to be correct. However, in the lab, you measure L1, pin 2, they have to be logic 1.
right.
If they not,
If they're not, then you replace it. You remove and replace.
no, not yet. At work, you do that way, but in the lab, it's not. The thing is, you build a circuit. Okay?
Uh-huh.
You build a circuitry.
Check the wires.
So, I can telling you, I connect the meter into U1 pin 2.
Uh-huh.
Then I can remove the wire.
Mm.
That means remove this wire, right?
Uh-huh.
Lift it up. If
Yep.
they go logic 1, that's telling you the wire go wrong.
Right.
If this one not, then you have to remove the wire U3 pin 3, right? If it's working, that means that wire going wrong. Okay?
Uh-huh.
At, at work, you cannot remove the wire anywhere. If you get input right, output wrong, Gen IC. Okay?
Uh-huh.
And now, another problem is check input U1. Data good. Okay. Check P clock. Okay. You need the software to do. Okay. Clock good. Then U1 pin 1 have to be low. Okay. Now, if U1 pin 1, okay, I go in that one. Right. Okay. Pin 1. I say, if U1 pin 1 not 0. Okay. Not low. Then that means you measure U1 pin 1 not low. What can we do?
Hmm. It's connected to U4.
Okay. That means now you have to measure U4.
Mm-hmm.
U4. Right?
Mm-hmm. Mm-hmm.
Okay. Check U4 pin 04 equal low. Okay. If not low, then okay. If you check the U4 pin 4, you want it low. If they not low, then what can you do?
Check PB1.
Correct.
PB1.
You check U4 pin 2, right?
Yes.
U4 pin 3.
Mm-hmm.
Okay. U4 pin 2. Okay. U4 pin 3 on low, right?
Mm-hmm.
Also here. And also U4 pin 1.
Right. That makes sense.
Okay.
Mm-hmm.
So that means completely you fix that problem. Even you asking me, I do the same thing, exactly what I telling you here. Okay. Any question regarding the test number 1? I just tell you a detail on the one test, okay? And the other test will be do the same way.
Right. Exactly.
So that's why if you know how to do what to do,
Mm-hmm.
then the time you in the class not enough for you to do what you want. So that's why I want to keep busy on the time when I'm in the class.
Mm-hmm.
I don't have to waiting. Okay.
Okay.
Time to go home. Okay. So
Okay.
that will be, let's see, the shoot. The lab 13 new. Okay, now you can see when you try to troubleshooting in the software, you have to set this breakpoint.
Mm-hmm.
Okay. Then when you run, you have to get the bug stack debugging. Okay.
Mm-hmm.
See that when they run up to this breakpoint here, they stop. If you keep going, you press F10. Okay. Otherwise, this is a function call. If you want to go into this function, okay, for detail, then you press F11. You can see I press F10. They go to enable function 2. Okay. F10, that means they go to the next line. Now, if I want to go into the enable U2, press F11. You see that? They
Mm-hmm.
go to the function enable 2. Okay. That is a software troubleshooting for anything you want to do with the software. Okay. If you press F10, they go next, they go back to here. Okay. That is how to using the software. Okay. To
Okay.
troubleshoot it.
Mm-hmm.
Okay. Now, on the test number 2, you test U1, U2, U4 for data AA. If they fail, only U1 or U2, not U4.
Right.
So you only need to check U1 and U2.
Mm-hmm.
Okay?
Mm-hmm.
U4, if they not working, they fail that one, not you. Okay? And then this one, you see that? I say that U1, U2, AA. And a peak of only U1, U2. Okay, U4 already passed. Now, this is the key point. that memory file for a data file address at location AA.
Mm-hmm.
So you know that expect file math will be FF and the peak of regarding into this test will be U3, U4, U5, U6, U7. Okay, let's see. They will be U3, U4, U6, U5, U6, U7. U7 here.
Yep.
So the way memory for all of the program, all of the way testing memory will be the same. This is the memory. Okay. Basically, they using only input address 1, 2, 3, 4, 8. That means you get 8 location. So you can go to power of 8. Okay. 256 location inside. Okay. You can write data into the memory. Then you can read data from the same location. Make sure they're the same. Okay. And for U5, you want to write data. Pin 21 must be 0. Correct?
Yep.
How about pin 20?
It's is it 1 or is it 0? Hang on.
What logic supposed to be
20 is 1
perfect?
and 21 is 0.
Yeah, you now you understand. U5 pin 20, that means output enable.
Yep.
Output. That means when you read, then pin 20 must be 0.
Yep.
And pin 21 have to be a 1 for reading.
Yeah, reading is
Logic 1.
yes.
Okay, now key point here will be enable. What they want when you apply address location here, enable must be 1. That means they not allow anything go inside. Okay, and when you apply the data here, also enable have to be 1. Okay, when you get address already and the data already, okay, now you want to write into the U5, then you can apply pin 21 logic 0, pin 20 logic 1, and enable at the 1, then 0, then 1. They just go to 0 to loading data into that location and have to be go back to 1.
Right.
Otherwise, if the 0 and now you change the address or change the data, they screw up inside. Okay?
Mm-hmm.
However, remember, when you're reading data out of the memory, pin 21 must be 1. Pin 20 have to be 0. Enable can be a 0. Don't have to go 1 to 0 to 1. The thing is now data just go out. They cannot coming in. So depend on your address, data will be coming out. That is the way any memory will be working that way.
Okay.
Now, U6 is a buffer bidirectional.
Yep.
Data can go from B to A, or data can go from A to B. Correct?
Yep.
Depend on U6 pin number 1 direction. If U6 pin 1, logic 1, data go from A to B. U6 pin 1 0, data now go from B to A.
Mm-hmm.
Okay? And also you get pin 19 enable. That means pin 19 0 and the U6 working. If they equal 1, look like they not connect here. Okay? Isolated. So, now, for writing data into the memory, first thing you writing the memory location AA. You write port A, 0HAA. They go this way. And now you need to apply the clock U3 clock here. Okay? So data from output U1 will be go inside U3. And now U3 output control the router. That means automatically data go to U3 inside. Automatically they go to outside. That's how that works. That means you get the address AA. Now you need to write the data 55. Then you have to write port A, 0x55. They're going out here. Okay, they're going down. And you have to set direction U6 to be a B, a 0. So data now go in outside, okay, of U6, and they will be going to memory data. And make sure you have to enable U6. Okay, that means after you already get address ready and you get the data ready, now you want to write data to that location. So you get pin 21, 0, pin 21, pin 18, high, low, high. That completely writing data to the memory. So that's why in the program,
Yep.
okay, in the program, okay, all the time we use it. First thing, that write address to memory. Okay. And after you write address to memory, now you need to write data to memory. Address ready, data ready. Now you call the function write to memory. Okay. And then you have to repeat the same with a different data, different address. Okay. Before you try to verify. Okay. Now, you want to read memory location AA. First thing you have to write a thread to let the memory know which location you want. Then you go into the function read memory. And this is a verified right or wrong. Okay.
Mhm.
So for the write to the memory here, okay, then you can go to the write to address to memory to see what they doing.
There it is.
Here, write address to memory. Okay. In here, I given to you, you need to write to port A. Then you need to enable U1 cloud, U3 cloud. Okay. That's what they do in here. Write to port A, whatever you want. Apply P cloud so they can coming out of U1 data. You enable U1 and you using U3 clock. That means they clock into the here U3 clock. They will be loading data into U3 and on already control output low. They coming out. That is how they working. Okay. And now for write data to the memory. So you apply data to port A. You need enable U1. You need U1 clock. You need U6 direction B to A. U6 enable. Okay. So that is the process they doing. Okay. Write port A clock enable U1 P clock U6 direction and write to port B. Okay. That for writing the data to the memory. And after that, you call a function telling write to the memory. So you can see in here, port D, okay, memory enable pin 2, memory write pin 3, memory output pin 4. So that's why you have to write port D0B, okay, port D090B. That means you want that to be one first 0, then 1 again. So data will be loading into the memory you want. Last one, read memory. You want to read, you need to apply address location. Then now you need to set U6 direction. Now from A to B. Enable U6 and to read memory out is 0. Memory write is 1. And memory enable to be 0. Okay? That means you read it.
Mhm.
Okay. So any question regarding into write data to memory, write address to memory, write to memory, and read memory.
No, thank you very much.
Yeah, I hope can help. Okay. Now this is the DA converter circuitry. US means input binary. This connect to the output of the memory. Okay. And they will be converting from binary to analog. However, they converting into the output current, I out pin number 4. And basically, after you build this circuitry, they already telling you, okay, connect the meter to U9 pin 3 at just the port here, okay, until you get 10 volt. So basically, they want 2 milliamp coming in ADA converter. Okay, so if you measure the pin number 14 here, they supposed to be round. The thing is one side 10 volt, the other side round. So the Ohm law, you can take 10 divided 2K. That will be 2 milliamp. Okay, and that 2 milliamp coming out, we cannot take care current out. That's why they adding this circuitry. That means the circuit converting current to voltage. That means 2 milliamp coming out times 5K. So you're supposed to get at the that point one is almost 10 volt. Okay. If they not, then whatever they show on the circuitry here, you just take it. Like I take US pin 3, I suppose to get minus 12 volts. And also, they can go through the capacitor to this pin. I take pin 1, ground. I take pin 2, ground. I take pin 13, plus 12 volt. Okay? And also, when you take U10, pin 3, ground. Okay? Pin 6 supposed to be 10 volt. Pin 7, power 12 volt. Pin number 4 minus 12 volt. Okay. And now, at pin number 6, they connect to R4 here. R4, R5, 10K, 10K, that means voltage divider. If you get pin 6, 10, at this point here, they will be half 5 volt. Okay. And that 5 volt. And now the capacitor here. Okay. This capacitor they adding here. Try to make sure if you get 5 volt here, and the capacitor will be hold that 5 volt for you. And you measure pin U1 11, pin 3 supposed to be 5. And U11 follower. Okay, unity gain. That means input, output the same. If you get 5 volt pin 3, will be 6, pin 6 will be 5 volt. And U12 pin 6 will be 5 volt. Okay. And this U12 A to D converter. That means input at pin 6 will be converting to binary. Okay. And if you try to build exactly following here, okay, then this binary will be go to the output of U13. Okay. And U13 will be connected to the port C. So you need enable U13 and you verify output. That's the whole thing they working that way. Okay. And what I recommend to you, when you build the circuitry, U1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, 11, 12. So the last part of your circuit board or the circuit board, okay, you can build either U10, U11, U12, okay, and the C1, C2, C3, and power will be in the last one. Why? The thing in the future, you can get the next lab will be almost the same. However, the circuitry for ADDA will not change. So you don't have to rebuild it again. You only build this part over here. However, the difference on the next lab, I'm not doing your software. I given you anything in order to develop the software based on the one we already did for you. Okay, any question, anything?
Yeah, I have a question. Okay, on the build, you're saying follow that order. There, IC13 isn't up there, so that would go after 12, correct? And then the capacitors and the resistors, I thought would just follow after the last IC. No?
No. You can build the last one, C1, C2, C3 on the right. Okay. U12 will be before connection for capacitor and resistor. Then before that, you can get U1. Okay, anyway, Monday I can see your guy. Okay?
Okay.
I will telling you how can we make it.
Okay.
The reason is later on the circuitry will be changing but not changing U10 or U9 or U8, U11, U12. So that's why you can build, okay?
Mm.
Later on, I changing up here, okay?
Mm. Okay.
Monday, I be in the lab, so I will be helping your guy to assign, okay?
Okay.
The pin, even to the end of the lab, this part will be keep the same thing, okay? I don't
Okay.
want you to spend time to build again,
Okay.
okay? Only changing whatever up here.
Okay.
Okay, any question?
Thank you very much. Good class.
Not a problem,
Perfecto.
okay? I make sure your guy know how to do, what to do.
Thank you. I appreciate it. I'm going to watch this video a couple of times over this weekend.
Okay, okay, so let's see. I hope your guy will get a very good weekend, okay?
Okay.
And
You
we'll see you on Monday.
Okay. Have a good
Okay.
weekend.
Good night,
My
everybody.
pleasure.
Good
Thank you.
night.
Good night, sir.
Bye-bye.
Bye-bye.